Welcome everyone to today's session on inductive charging for battery electric buses. We're excited to have you join us as we explore this innovative solution towards transit decarbonization in Canada. While we give everyone else a few more moments to join in, I'll begin with my land acknowledgement. Next slide, please. As we gather virtually today, I want to acknowledge that we are connecting from many different parts of Canada, each with its own unique history and relationship with Indigenous peoples. I am currently joining from Calgary, and I would like to take this opportunity to acknowledge the traditional territories of the people of the Treaty 7 region in southern Alberta. The city of Calgary is also home to the Métis Nation of Alberta, Districts 5 and 6. CUTRIC's commitment to reconciliation extends beyond this land acknowledgement. CUTRIC is dedicated to meaningful actions that reflect its values of inclusion, equity, and sustainability as we all work towards a just and greener future for all. Next slide, please. Today's session is hosted in a Zoom meeting format as opposed to a webinar format. So you can see the other participants. If you can, please turn on your camera. We have 5 presenters lined up today. We encourage you to rename yourself to include your organization, such as in my example here, I put JennyBot, CUTRIC, so that when you do ask a question to the presenters, they can answer you within the context of your work. So to do this, you can just hover over your video, click the 3 dots, or you can click on the participants icon at the bottom and select more as shown on this slide. So I think most of you have settled in. Welcome again. Wait, let me just admit some more. Next slide, please, Jess. So here is our agenda for today. I'm going to start with a quick project overview. And an overview of CUTRIC's commercialization framework before we begin the presentation. So today we have CALSTART, Damera, Electreon, InductEV and WAVE Charging. And then I'll just quickly close with some next steps. At the end of each presentation, we'll have around 5 minutes to answer questions. Next slide, please. So today we have both CUTRIC members and non-members. So let me have some time to provide a brief introduction to CUTRIC. So we are a nonprofit consortium with over 130 members. Over a quarter of our members are transit agencies, with our remainder comprising industry, utilities, and other organizations focused on transit innovation. Our vision is to make Canada a global leader in clean and smart mobility, and our mission is to support this through commercialization of technologies. So we do this through industry-led collaborative research, development, demonstration, and integration projects. In line with this, we're continuously exploring solutions with our members. So as I mentioned, we're consortium-based. When inductive charging emerged as a potential solution, we initiated discussions and conducted a survey. This was in April 2024. We surveyed our network to gauge what the interest is in this technology, and we received responses from 26 transit agencies, ranging from being somewhat interested to very interested. So we took concrete steps towards understanding this technology more together with our members. So we had 2 consultation sessions late last year. In November, we talked about how we do commercialization projects in CUTRIC. And then in December, we invited presenters, most of whom are back here today, to talk more about the technology as well as what's happened in deployments outside of Canada. So in a nutshell, that's why we're here today. We're going to explore this technology together and see if we can have a Canada deployment. Next slide, please. So The project title is the Pan-Canadian Battery Electric Bus Demonstration and Integration Trial, Inductive and Autonomous Charging Phase 3. So it's really hard to say. We call it eBus Phase 3, but there's a reason why we have this very long and descriptive title. It already tells you what the project is all about. So it's Pan-Canadian. Our commercialization project aims to go beyond just a single city or a single province. Because of the unique challenges that we know are in different cities and provinces across Canada. We want our project to cover more than one agency in more than one province as much as possible, so that the results or outcomes of the project could be used for wider adoption across Canada. We mentioned that it's battery electric bus to make it distinct from our other commercialization projects. We do have another project, the fuel cell hydrogen bus project, and we also had before a smart vehicle project. We call it a demonstration and integration trial because we want it to be distinct from a pilot. For a demonstration and integration trial, we expect the participating transit agencies to continue using this technology. So it's not going to be a pilot that ends at the end of the project. And of course, the goal is to be able to demonstrate the technology and integrate it into the complete transit system. So for this project, we are focusing on inductive and autonomous. There are two elements. The first, inductive charging, is what we're focusing on now mainly today. We can cover autonomous driving at the later session. And lastly, it's phase 3 because we've already had 2 previous phases for battery electric bus. So, sorry, I meant to say phase 1 has been completed. It ran from 2019 to 2024. We demonstrated high-powered pantograph chargers, and the outcomes of which contributed to the development of the J3105 standard, which promotes interoperability. And phase 2 is being led by Jess Smith, who's on the line with us today, helping me. It was launched in 2024. It expands on phase 1 findings on battery electric bus technology and looking towards more interoperability issues and efficiency. So it will run until the end of this year. Next slide, please. So what is a CUTRIC commercialization project? So we start with market feedback, which is where we are today and what we started last year. So we have identified what technology we are exploring. We understand which agencies are interested. At this time, though, I want to just to make it clear what we have no firm project boundaries on what the type of vehicle is that we're using in terms of the size, on the number of vehicles, or even whether we're doing static or dynamic charging or both. We don't have that defined yet now because our intention is to work with our transit agencies who will participate and see what their needs are, what their capabilities are, like in terms of their location, what could work, what size of bus, static or dynamic. So that's not yet defined at the start of this project. Later on during the presentations, you'll understand like what different kinds of deployments there are. So that will be really helpful. So after this initial phase of market feedback, we'll do a wider market scan. Once we have on board those who are interested, then we'll try to understand better what's offered in the Canadian market. And then we'll do budgeting once we have that and we have our scope defined, we can budget, and then together as a consortium, we can lobby for funding. So that's not something that should be at top of mind too much yet at this time, because we will lobby for government funding as a group, and then you understand better what the financial considerations are for joining. And then once we all have that in place, we can launch the project, hopefully by the end of this year. Next slide, please. So I promise this is the last slide that you'll hear from our presenters soon, but I just wanted to highlight the key elements of a CUTRIC commercialization project. So our projects normally go through technologies that are in the range of TRLs 5 to 6. You'll probably hear from Katrina's presentation later that inductive charging right now is around TRL 7, technology readiness level number 7. But I believe that's just for specific components of the technology. But what we want to demonstrate is a full integrated system. So that's what we're looking at for this project. And we will proceed with this project if we have at least 2 transit agencies on board ready to deploy as part of this project, ideally 3, and multiple technology partners. For suppliers and as well, we would hope for multiple ones before we proceed. And we consider in our projects transit agencies as the champions of the technology. So it really requires a commitment of time and resources. We want to say that up front. You have to be willing to be a first mover to join our project, because definitely there will be challenges along the way during the demonstration, but that's why we have the technology providers and manufacturers as part of the project team, so that we can resolve those challenges together in a more efficient way. Every project that CUTRIC has is bound by a memorandum of understanding, so it will formalize the collaboration. It will tell you how long of a period you're expected to be part of the project and committed to it. So typically that spans 2 to 5 years. Additionally, partners also sign a non-disclosure agreement as part of this project to ensure that data sharing and IP protocols are agreed to by the whole team. And CUTRIC, our primary role is conducting rigorous empirical analysis to validate the technology's impact, and how we go about facilitating funding through program fees and public grants and additional contributions from industry as needed. Our analysis will provide essential data to inform decision-making and to demonstrate the technology's value, so that we can de-risk the technology for the rest of the transit agencies in Canada. So that's a lot from my end. I just wanted to frame the conversation. But in the next slide, you'll see that we have a full agenda of presentations today. And without further ado, I want to turn it over to Katrina Sutton of CALSTART.
Awesome. Thanks, Jenny. Hello, rectangles here. I'm Katrina. And so I work at CALSTART, which is sorry, I've just lost the tagline. We're working to accelerate zero-emission transportation sort of throughout. The Cal is a misnomer. We don't just work in California, primarily in the States and Canada and some other international work. So it's very exciting. Next slide, please. So today I'm going to talk about an industry report that I recently released on behalf of the FTA, looking at the effectiveness of wireless charging for electric transit buses, which I think is sort of going to provide a pretty good overview comparatively to the rest of the speakers that are going to go after me. So without further ado, next slide, Jess, please. So just starting kind of high level, thinking about what wireless charging is. So there's no physical contact in when you wirelessly charge a bus. It's called inductive charging, wireless power transfer, if you want to be very fancy about it. And so essentially what happens is you have some wireless charging plates installed on the bottom of the vehicle, like the picture on the bottom, and then you have a pad located on the ground, and you just drive the vehicle, the bus in this case, over the pad. They do some communication, and you've got power transfer, and it's very exciting, and it's pretty hands-off, and it can be really great for when you have about 10 or 15 minutes to sort of charge throughout your day. And, if you're lapping, every lap, every other lap, you come back to the same place and you have a couple minutes to charge. It works really well for that style of routes. There's 2 types of wireless charging, which is static and dynamic. Static is, as I just described, you're sort of sitting on a location, not moving and receiving power. Whereas dynamic is really interesting, where you're moving and charging at the same time. My research focused on static, so I will be talking about static, but I just think it's a good point to bring up that there is another type as well. The next slide, please. So thinking about like advantages, disadvantages to wireless charging, I'm not going to go through every one of these points because we all can read here, but I think a big one to think about is right sizing the battery capacity. So, if you have a battery, you have a vehicle with a battery, you typically anticipate you need the battery to last all day, and then you go home to charge at the end of the day. But when you do wireless charging and you're charging throughout the day, you don't necessarily need the same amount of battery capacity as you would when you go home, when you only charge at home at the end of the day. And so therefore you could, in theory, have less can have less packs on the bus, which therefore can lead to a lighter bus as well as a lower cost. And then a lighter bus, of course, will be more energy efficient. So it's a different way to sort of consider charging the vehicle and making sure that you can complete your duty cycle throughout the day. The other interesting thing is thinking about cleaner charging. So I live in California. We have a lot of solar. So, throughout the day, you get cleaner energy while you're charging the bus versus at night, they're stereotypically a little bit dirtier. So thinking about the sort of the upstream emissions when you're doing some charging. The last kind of interesting advantage I'll just highlight is thinking about labor considerations. So the buses, typically when you have the unions involved, you have one union for charging or for refueling and for maintenance, and then one for driving is sort of how I've heard it laid out. And so when you have no interaction with the bus, you can just you don't have to have somebody come out to plug in the bus while you're out in the world. So that's interesting. The disadvantage I will highlight is the weight increase. So you do have, additional equipment on the vehicle. And so it is just something to keep in mind that the bus will be heavier. I won't talk about like specific numbers because it sort of varies, but that's just something to keep in mind. But it could also be mitigated by having fewer packs on the vehicle overall. Next slide, please. So I looked at the standards of wireless charging sort of throughout the world, and I won't bore you with my beautiful table that I have on the actual report because it's large and fairly terrifying. But the biggest one to think about is the SAE standards. That's pretty much like what we like to talk about. And J2954-2 is really the important one for wireless charging in transit applications, and it's actually still in progress. So it's not published, it's not ready to go yet. When I spoke to folks, they were expecting it to come at the end of the year, but there's still some work to be done. So it's just something to keep in mind when you're considering adopting this technology. Next slide, please. So part of this research was not just sort of giving an overview, not just looking at the policies and sort of the standards, but it was also thinking about chatting with folks about wireless charging and their experience with it. So these next couple of slides are just going over the results from chatting with transit agencies, charging manufacturers, as well as vehicle OEMs. So just keep that in mind. So everybody's experience is their own. It's not necessarily representative of the industry, but it is just something to keep in mind with when you're considering wireless charging. So looking at transit agency feedback, the biggest thing that they noted was that, regardless of what type of technology was charging the bus, they all had to do some route adjustments with the electric buses just as a whole. And so the concern can also be that when you're doing wireless charging, you have to kind of redo the routes to make sure you have enough time factored in for the wireless as well. Because I think we were noting that they like to sit for about 10 or 15 minutes. And so if your blocks don't have the time to accommodate that, definitely something to keep in mind. The other thing too they brought up was charging infrastructure and like power to offsite locations. When you're home charging, when you're depot charging, you generally have control of that space. You have a couple of acres to kind of put your buses where you want to put them, put the charging infrastructure where have you. But when you're out in a public, when you're out at the city space, there's a lot of ownership issues is sort of the headache that's been brought up to us. So thinking about like public right of way, installing an additional meter, having to do some trenching, sort of what have you. And so that's just sort of just something else to keep in mind when you're not on your own property that could result in just some additional time to keep in mind. Next slide, please. So moving on to charging company feedback, the biggest thing they wanted to highlight that they highlighted to me, I guess, was thinking about funding opportunities. So a lot of funding opportunities, when you read the fine print, it has to have, an industry standard, which is not necessarily complete at this time, or at least when I did this research. So it's something to keep in mind that you could be, fighting an uphill battle on that front. The other thing to think about is the language of the opportunity. So, well, sorry, there's a weird noise. So the language of the opportunity is, so thinking about a lot of programs will have like one charger per bus, which is not necessarily the situation for wireless charging. You can have, you have one pad and you typically can have, 3, 4, 5 buses that kind of use that pad throughout the day. And that's just a different way to structure the charging. And sorry, I'm reading my notes. So the funding structure like that is saying that, plug-in charging, each bus has its own charger, and each charger will receive funding. And with wireless charging, you have one charger, quote unquote. So you could in theory be receiving less funding, even if there are multiple or, the same amount of buses that are able to charge throughout the day. So just something to keep in mind, that when you're looking for funding or really thinking about how to structure these programs, is to make sure that it's, inclusive of both wired and wireless charging technology. Next slide, please. And then thinking about vehicle manufacturer feedback. So we chatted with some OEMs. The 71% of them were experienced with wireless charging, whereas 29% really hadn't done any work on this side. The biggest thing that the experienced ones wanted to point out was that they really valued robust partnerships with the wireless charging companies. And at the end of the day, they really only worked with one, just based on sort of the engineering and the partnership and the relationships between the vehicle and the charging manufacturer. The other thing to keep in mind was that there's a hardware versus software integration. The hardware was arguably easier to install. While there's no requirement for the location of the hardware, they all pretty much put them behind the front axle of the vehicle, if that helps you visualize where they are on the bus. But actually the software and sort of the communication engineering was shockingly difficult, was what their feedback was. So something to keep in mind just as a fun fact. The inexperienced one, this quote here, I think is really funny, and it sums it up really nicely. This particular OEM did not want to, even entertain the notion of wireless charging until there were standards and what they found as an acceptably solvent company to work with. So, that's also something that the OEM, the charging manufacturer, and, the transit agency themselves all have to work together to make sure that there is a good product and that will keep the buses operating, because that's what we want, right? We want to move people around. So next slide, please. So again, this report was really targeted towards the Federal Transit Administration in the States. So this is sort of kind of the conclusion, thinking about what the FTA can do to really keep considering wireless charging as a viable option. The biggest one that I think is education. I'm personally just really big on education for zero emission technology across the board. So it was really nice that the results actually did keep, like, it was not a surprise to me that, other folks agreed that education was important when trying to push this newer technology out into the world. So it's really important that folks can have an informed decision making. They have all the information available. So, webinars like this one with CUTRIC, I think, is really valuable when you're thinking about, what will work for particular transit agencies. The other thing too, I think, is interesting is thinking about funding and making sure the opportunities are sort of written agnostically, to make sure that, the opportunity, or sorry, the technology that works for the transit agency is, available to them. Because otherwise, you don't want to, what is it, like, you don't want to put this square peg in a round hole or something like that. There's some expression, but, really thinking about what will work so you can have a good operation, because you don't want something that doesn't work for you. It's just not good. And then, finally thinking about nascent technology, like, we're still working on it, in my opinion. And so making sure that you can make an informed decision and, like, a robust technology that will last the duration of the vehicle as well. So next slide. This is just like a fun little slide I tossed in. So if the slides are shared, this is the cover of the report, and it's like clickable, but I'm sure you can Google it and find the report if you want to see all the words, if not just listen to me talk. Also just pointing out that CalSTART is doing a few wireless charging projects in the States. Excuse me, like with UCLA down in Southern California, as well in Michigan. Excuse me. Sorry about that. Well, that's pretty much it. You want to continue on?
Thank you so much, Katrina. Those are very useful insights. I actually really enjoyed reading your report. It was very informative. I think it was really good to hear from an agnostic perspective as well, and from learnings from deployments in the US. I encourage everyone, we have some time to ask questions directly from Katrina before we proceed to the next presenter. I know that there have been questions in the chat, and our presenters have been kindly responding to them as well, if that's your preferred method. But it would be nice if you go on camera and ask your question, though. Anybody can raise your hand or unmute yourself to ask a question. If you think about it later, that's fine as well. You can ask it towards the end. Thank you again, Katrina.
Yeah, thank you guys.
Yeah.
Everyone is just wowed by the presentation.
I
understand.
know.
It's just speechless. So, but I'm here. I'm a
Exactly,
real
that's
person.
the word, speechless. Thank you again, Katrina. And now I'd like to proceed to the presentation from Damera for Roman Black. Hi. I turn the mic
Hello,
over.
yes, good afternoon, everyone. Do you all hear me, just to confirm?
Yes.
Okay, excellent. So thank you very much on behalf of Damera Corporation. So shall we start the slides? Okay, great. Next slide, please. So about Damera Corporation. So the company started in 2002, where it brought us to where we are currently. So over 23 years where we've been in existence. Where we provide technical repair services to transit buses across Ontario, mostly across Ontario and portions of the United States and the rest of Canada, such that we service over 3,000 buses per year, every year. And the great thing about this is that we get a lot of exposure to different brands of buses, such as New Flyer, Nova Bus, Prevost, MCI, Van Hool, where we come across what are some of the design issues with those buses, what are some of the production issues, and we learn a lot from those, which are great lessons learned in us being able to improve our repair services to those different brands. Next slide, please. So one of the partners that we're partnered with, Damera that is with Karzan. Karzan is a Turkish-based OEM of providing electric battery-powered buses only, and only electric battery-powered buses. Some are hydrogen fuel cell powered, but mostly they're electric battery-powered. And also autonomous vehicles as well. So autonomous driven electric battery-powered buses. And so we are an exclusive distributor of Karzan on behalf of the North American market, which I'll showcase in a moment of exactly which buses we market on behalf of them and distribute and service. Next slide. So they make a bunch of models, but the one that we particularly focus on for the North American market is called the E-Just. The E-Just is basically a full electric battery powered minibus where it has a length of 6 meters to be specific, just under 20 feet long. And it's a very cost effective bus that is used for reduced lower maintenance costs because it is electric battery powered, and it's a relatively small size. As I said, it's only just under 20 feet long. So the amount of consumption of charging it takes for 6 to 8 hours of service, it only costs about $4. So it's quite inexpensive compared to any other, never mind diesel powered bus, but because obviously it'd be much cheaper than that. but from operating cost standpoint, but also from any larger electric battery powered buses that are, let's say, 40-foot long or larger. So very cost effective. Next slide, please. So the great thing about our solution of providing the e-Just is because it's not a cutaway, so its operating costs are quite low, and also its capital costs are low over the life cycle of the bus, because the life cycle expectancy is approximately 12 years long, if not more. And so it's an effective tool for on-demand requests or on-demand transit. So it can be like a minibus used to feed the main feeder line. At the same time, it can take one paratransit vehicle, so mobility device or wheelchair, onto the bus, where there's an additional 10 seats available for regular passengers, and a handful of more space available for people just to stand in the bus. So being an on-demand type approach, which is similar to an Uber type approach, it becomes much more cost effective to take that type of transit on-demand bus compared to an Uber vehicle. Because the way it's laid out, the way the transit route is laid out, it becomes much less costly compared to simply calling one vehicle to pick up one person through an Uber approach. Next slide, please. So it is a low floor minibus with zero emission for North America. And because of its intricate geometrical design, it's quite narrow, so it goes down. You can easily go down very narrow streets. Wonderful for residential roads, easy for tight turns compared to larger buses. So very versatile for the different driving geometries that are demanding of more privately designed streets. Next slide, please. So just giving you a bird's eye view of some of our larger customers, and the number of customers we have is actually much more than this, just to make that clear. But these are some of the larger customers. So the first customer in Canada, for that matter, is the city of St. John Transit in New Brunswick. They currently have 6 buses. There's some more in the pipeline of purchases to come. So just to give you an idea, for Oakville was the second largest transit purchase in Canada. So Oakville, Ontario, they currently are running 15 buses, and they've been running it now for approaching 2 years, actually. And then one of the larger US customers is in Santa Maria, California. They currently have 14 buses on the go, and they're also looking at additional purchases. And then we have a large handful of customers in the state of Massachusetts. The first one was Nantucket, Massachusetts. They have currently 5 buses. And then recently delivered buses have also have been purchased by Nantucket and also Martha's Vineyard in Massachusetts. And in the state of Minnesota, next to basically a suburb of Minneapolis, St. Paul, is Minnesota Valley Transit. And I apologize for the spelling mistake there. It's not Valerie, it should be Valley. So we recently delivered them about 2 months ago 5 buses. So they're in the process of making them fully operational for their transit route. And one other important customer I want to mention. So the city of Bradford, West Gwillimbury, which is just immediately south of the town of Barrie, Ontario, we're starting a nice little pilot project there, 4 buses, that is in partnership with a company called Argo. And they are basically a software platform provider that is started the leadership team. They're actually a mixture of leaders from Tesla and Uber. And so you can see where that leads to. They developed a platform that is an on-demand transit approach, and they're using the e-Just buses as a test pilot. So we're really excited about this opportunity because from what we know and see, it's going to become quite successful, very cost effective to the customer, that will and may very likely become quite successful with other towns in Ontario and hopefully throughout Canada. So next slide, please. So from a charging perspective, so far, the only way to charge the e-Just is through wired charging. And we use lithium-ion batteries. And the platform of suppliers of chargers is most often we use ABB and ChargePoint, but there's also options of Siemens and Siemens/Helios. To give you an idea that the time of charging, so for level 3 fast charging, starting from 20% charged and to bring you up to about 85% charge, it takes just under an hour to charge it, in 58 minutes. However, I want to mention that an important point of that is, as a matter of fact, I was just personally driving the vehicle myself yesterday, participating in some marketing videos. So if you see me on Stars or MTV, it's because of the e-Jest. So, so the great thing about it that I personally experienced is its braking regeneration capability. So when you drive the bus in a constant stop and go platform, you pretty much don't need to charge it ever, because every time you want the bus to slow down, and when you have it in a regenerative braking regeneration mode, the regeneration back drives the electric motor and it charges the battery. So I'll never forget this. I drove for almost 3 hours yesterday. I started with a range of 192 kilometers. I came back with a range of 195 kilometers, and I did not charge it at all. It was actually quite amazing. I was truly stunned. When you do notice that the battery gets depleted is when you're going on a long trip. So when you're driving for half an hour, 20 minutes, and you're not stopping much at all, you'll notice that the battery gets obviously eventually drained to some extent. But when you're stop and go, it actually is to your benefit. Next slide, please. Now, we did look into wireless charging, specifically the product offered from InductEV, a great product, by the way. We determined that it wasn't feasibly possible to put it onto the e-Jest platform, as we call it, the 1.0 platform, because of the space constraints and the additional equipment that had to go on there for cooling purposes. It just unfortunately didn't work out. And from a business case perspective, it made no sense, unfortunately. However, we are in the process of designing a new bus. It's called the 2.0 model, and it will be incorporated in that model as an option. So the 2.0 model will be offered a wired option, or if the customer wants a wireless option, which it will be the InductEV option. Next slide, please. So that being said, with the fact that Carzen has actually developed autonomous self-drive technologies, level 4, that technology actually, in the next slide there, I'll show you in a moment, they've actually, to this date, have proven their autonomous technology to be quite successful. And so that technology can be slightly improvised to be used for positioning at this point, the 2.0 model autonomously, so that it's most efficiently located when it's approaching the point to be wirelessly in charge through induction. And so that's one of the great things that we pride ourselves with that will be accomplished. Next slide, please. So just to prove and show some validity here regarding autonomous technologies, currently Carzen, as I mentioned, they make different sizes of buses, e-Just being the smallest one, being 6 meter long, just under 20 feet long. They make a bunch of sizes which go all the way up to articulated buses, 60-foot longs, but they make a different sizes. The one in question here that I'm showing in the upper right-hand corner is approximately a just under 30-foot long bus, and is basically 8.3 meter long bus. And it is outfitted with technologies for autonomous self-driving capability. This model with this autonomous technologies has been in operation for just over 3 years, actually, since 2022 in Stavanger, Norway. And I had the opportunity in meeting the Transit Authority leadership just about 2 months ago to confirm this. And what I was truly astonished by was that I asked them a blunt question. I said, so how many incidences have you had of driving the autonomous technologies for the last 3 years? And I couldn't believe the answer. They said 0. So my jaw dropped when I heard that. So So just to give you an idea, this is it's a full looping route where they are driving not through a dedicated lane, but they're actually driving through regular city traffic, and they're going through traffic light intersections. And in addition to that, it drives through an 8-meter long tunnel, and it's able to pass vehicles on its own within that tunnel. So truly amazing technology. And so it's been very self-proven technology. And so the same technology is being incorporated for the EGES. So the EGES is being currently developed to also have a self-driving platform for transit applications. And it's expected to be debuted as the first demo in America, actually in the United States, Q2 or Q3 of this coming year. Next slide. And that's pretty much it. I thank you very much for your time. And if there's any questions, please feel free to ask them through the management of Jenny Dubu.
Hi, thank you so much, Roman. That was really interesting, and thank you for sharing your experience in collaborating with InductEV. I think that's really a good insight and the plans for autonomous driving in your products. Did anyone want to ask questions while we're online and live? It's great to hear other people's questions as well on camera so that everyone else can hear the response. Yes, Jess, go ahead.
I've seen the level 4 autonomy, and that excites me. I'm just wondering if you can speak to the fact that if that can be mixed traffic or dedicated laneway.
Both.
Perfect. Thank you. And
Yeah.
is there any concerns with left-hand turns with that technology?
Nope.
Wonderful. Thank you.
Yeah. You're welcome.
Those were very good questions. Majdi, I saw your hand raised earlier.
Yes, sorry, I'm getting over a call. I have my camera off, but thanks, Roman, for the presentation. And I don't know if I missed that point, but I'm actually curious about the inductive charging vehicle assembly. Like if you work with one OEM, can you actually have it interoperable with different OEM, or like is the development has to be with one partner at a time?
Well, you have to develop, you have to integrate, you have to perform design integration of the InductEV charging system with every OEM separately, because each product is different. So there's a separate integration effort. So if you want to integrate it with our bus, with Damera, the new bus that we're developing for the 2.0, integration is required there. If you want to do it with a Carzen bus, separate integration effort is there. If you want to do it with New Flyer Nova bus, the same thing, separate for each type of platform. So I think that answers your question.
Yeah, it does. So basically, any OEM you can develop for inductive charging, but for that platform of the bus. And if you
Yeah.
do that development, can you actually switch between OEM?
Well, you can
Okay.
like the InductEV product can be used for any OEM, but a
Okay.
separate effort of integration is needed.
Okay. Yes.
Yeah.
All right. Thank
Yeah.
you so much. Yeah. Thanks,
You're
Ron.
welcome. You're welcome.
Yes, Conrad, go ahead.
Hi, folks. Just a quick question, Roman. Do you have a timeline when the 2.0 version of the EGES might be available?
Yeah, the 2.0 from a production, like a production ready perspective, they'll be ready for new upcoming customers, because we do have an existing customer that we were really excited about that it was awarded to us. Outside of that customer, for new upcoming customers, we're presenting that the 2.0 model for production ready, it will be in early 2027.
Thank you so much for your questions, guys, and thank you, Roman, for your presentation. I hope
welcome.
everyone's taking note of Roman's contact details on the screen. Now, in the interest of time, I'm going to proceed with our next presentation. Our next presenter is Amit Sumergalai from Electreon. Hi, Amit.
Hi everyone. Thanks for having me and glad to be on. I'll get right to it. Next slide, please. Excellent. So as we've kind of been highlighted from the CALSTART presentation, one of the key features of Electreon's technology are both static and dynamic capabilities. Since our last kind of discussion here, we've brought up basically a product that's tailored for bus transit and specifically BRT lines to optimize all charging opportunities without the need for dedicated charging stops within your operating blocks. So you can continue operating as you would entirely, without kind of any stops, dedicated stops for charging or anything like that. With that in mind, you can, achieve a same or slightly better range than your ICE vehicles potentially. And through kind of the process of the project definition and analyzing the different routes, we can find that perfect balance between, static and dynamic charging to meet your route needs and your vehicle needs. Besides that, we also have a fully underground system. So it's completely outside of the public view. It's everything is underground, with access for maintenance and upgrades and all that. So there's no visual impact or obstructions. Besides that, we've also completed the first round of testing with the SAE group, and you see the pictures down below at the test track in Utah. We're currently installed on a Class 8 Kenworth truck, but same system can be installed on a transit vehicle. We have a second testing with that group planned later on this year, and it's all part of the CRP group, the working group on wireless dynamic charging. Besides the actual physical components and the SAE testing, we also feature a robust software package for fleet management. As fleet managers, you can, in one instance, get a complete snapshot of your fleet, where they are on the globe, and also about their charging, any system issues, anything that's down in maintenance. You can see your vehicle state of charge. You can say, okay, that vehicle, I want to prioritize charging when it gets back to my depot. We can actively tailor the charging windows or the charging times to take advantage of reduced grid costs or electricity costs, or for load balancing if you need it within the site, incorporating energy storage systems or solutions, and those kind of things. In addition to that, we have software APIs to either integrate with your existing software, or we offer, OCPP level charge management options as part of it as well. Next slide, please. In general, the system overview is fairly straightforward. We offer the dynamic, the semi, and the static systems. The system is made up of the ground system and the vehicle system. Ground system is all installed underground throughout, whether it's a short, static system above a bus station or a parking spot, or a dynamic system which is spread over several meters, 100 meters, depending on the space available and what comes out of the route analysis. Next slide, please. In terms of our kind of main active deployments, we have our customer in Detroit, as kind of Katrina mentioned with the CALSTART. On the screen here, you see basically our running bus depot in the Middle East with our public transit operator, and it's also a snapshot of our fleet management software. Basically, you can see the map with all the buses that are parked overnight now getting charged. On the right-hand side, you see a convenient bar showing the entire fleet and their state of charge, and you can see that they're pretty much all in charging mode. One bus has an error that brings it up, and through us or the on-site managers, we troubleshoot that and get to the bottom of the issue very quickly so that the bus can continue operation the next morning as it's needed. There's also some other vehicles still doing their rounds. As you can see, a little bit hard to see, but there's a triangle icon still on the roadway leading up and back to the charging site. Besides that, we have a public transit operator in Norway with a smaller bus fleet currently. It's a pilot stage with high power charging on their vehicles. Next slide, please. And this is just a global snapshot. Our headquarters are in Israel, but we have a very strong global presence in Europe and the US and in the Far East in China and Japan. Many partners, many projects going on and partners. Yeah, I think that's it. Next slide. There we go. Questions?
Thank you so much, Amit. I think this is a good chance to ask questions, especially about dynamic charging and Electreon's experience deploying this technology globally. Do you have any questions, please? Yes, Majdi.
I thought I'll kick this off since no one is asking, but I'm just gonna talk from maybe transit agency perspective, like considering the cost. Of course, I'm not really expert in technology, but if I'm looking at a static charging versus dynamic, I would imagine that in-motion dynamic charging would cost a lot because you need to provide the coil every, I don't know, meter or less along a length of the road that could be several kilometers in order to provide the charge you need to extend the range. So can you, at a high level, explain to all of us what these costs are compared to conventional pantograph or static inductive charging?
Yeah, sure. So the key portion of it, and you're correct. I mean, the dynamic charging is more expensive than static charging. And we don't look to install, kilometers of dynamic charging, look to install, tens or hundreds of meters in critical locations. And basically we're taking away or downsizing charging that we would need at the depots or other ways and bringing those charging and that cost to support the dynamic. So in the end, it can be almost a break even. There is considerably less a cost impact than pantograph or other high infrastructure solutions. Let's put it that way. So it can be competitive and comparable.
Thanks.
Go ahead, Katrina.
Yeah, thanks, Jenny. Great presentation, Amit. I think I've seen it a few times, and every time it changes and keeps getting better. But I just was curious from your perspective. So, like, obviously, this whole chat is about transit, but have you had any situations with not just transit, but maybe like a few different fleet types sharing especially the dynamic infrastructure and how that relationship might work at present or maybe in the future?
Yeah, absolutely. It's a very good point. One of the key benefits of our system is no matter the vehicle type, as long as you have our vehicle-based system, you will be able to charge on the dynamic or the static system. Whether you align above one in-road charging coil or several, depending on the vehicle length or the vehicle type, all the magic happens on the vehicle side to adapt that input energy to what is required by the vehicle. So with the same energy, such as our project in Michigan, we could charge a private vehicle, charge a city transit bus, charge a last mile delivery, and those are some of the things that we are incorporating with our projects, whether it's UCLA or with NDOT.
But like, do you have any instances where like this has happened? Sorry to
Yeah. I mean,
okay, I just wasn't sure because like it's really cool and interesting, but I just wasn't sure if there are any instances of it like happening versus like it's possible. You know what I mean? Like boots on the ground versus like pie in the sky.
Yeah. It's happened several times. deployed and in testing and in all the different stages of as we've done.
Cool. Thank you.
Thank
Sure.
you for that question, Katrina. I see your hand raised, Conrad. Go ahead.
Hi, Amit. A quick question around if one thinks from a city perspective, if you're installing this kind of infrastructure, there may be competing priorities with installation requirements, looking what is in the public right of way already. Maybe utility lines, curbside policy may be an issue, things like that. Have you any information that you can share with about experiences with installation timelines for this infrastructure, and if any advice around how to minimize those timelines from ideation to in the ground?
Yeah, no, it's a great question. We're dealing with it on several different projects, all at slightly different stages. In the end, when we do the actual in-road installation, it's fairly quickly. We've done in our Michigan project, we've done 300 meters in 24 hours from end to end. The road is paved, you can drive on it. So the actual installation is very quick. The preparation, the planning, all of that is usually the heaviest lift, especially with it being such a new technology. A lot of the utilities and the processes within the city or within the municipality, it's about bringing them up to speed with the technology, how it works with other utilities. Does it impact my fiber optic? No, it doesn't. And going through all these motions, and we'll be able to help and to provide information that we've had with our current experience, past and present, and depending, to help address any concerns. Installing in proximity to an airport and dealing with FAA, and so all these things I would say 95% we've dealt with them before and are happy to support and to make sure the process is as easy as can be. Let's put it that way.
Great, thank you.
Thank you for that question, Conrad. And Amit, I see a question in the chat. I'm not sure if it's addressed to you or to everyone, but from Aman Rai. Do you have any high-level installation or running costs? Or is that something that you're able to share now?
Not exactly. So running costs are very low. Everything is automated. We have automated telemetry of the system. We're constantly monitoring it and operating it. Everything is automated. Once the vehicle's above it, it gets charged. Installation cost, because, and this has been our experience, at least within the US and our projects in Europe or in the Far East, because of whether it's construction unions or the different rates of labor in each location, it changes so much that to really answer the question, I wish we could. It really depends on the location and the scope of the different projects. We'd be happy to kind of answer it with a little bit more information specifically. I hope that helps, Aman. I'm sorry I couldn't answer more.
I think that's helpful. I think you listed like the factors that go into the actual cost, so it can vary depending on the situation and the location. Thank you for your answer, Amit. Do we have any more questions? We still have 1 minute before we move on. We can accommodate one more. Okay, I don't see any hands, but you're welcome to chat with Amit if you have any questions. And we now move forward with our next presentation. Thank you again, Amit. And now I bring to you Adam Halsey from InductEV. Welcome, Adam.
Hey, can everyone hear me okay?
Yes, very loud and clear. Thank you.
Perfect. Okay, and I've actually got the chat window here open on my screen. So if anybody wants to ask me something in real time, I will do my best to address it. All right, so thank you, CUTRIC, and everyone that's joined to learn more about wireless charging. Today, I'm going to give you some background on InductEV, show you our system, review an example deployment, cover the vehicles we're available on, and then answer your questions at the end. So next slide. Little about InductEV real quick. We develop and manufacture high power static wireless charging. So static only and very high power, considering the footprint of our charging modules. Anywhere from 75 to 450 kW, but it's modular, so they're always made up of 75 kilowatt modules. We have been doing this for 15 years now, and we have projects in deployment for 8 years now in continuous deployment. We have about 130 wireless transit buses on the road. All of them are in the US currently, and we have about 160 vehicles in total. So beyond transit, which is our bread and butter, we do have yard trucks, and we also have some light vehicles as well. Specifically, we provide charging hardware and software to end users, vehicle hardware, so vehicle hardware to bus manufacturers, and we also provide all of the technical support for all of those products. Next slide. Okay, so here are the main components for a typical system, which is in this case 300 kilowatts. This would be deployed on a full-size bus in an opportunity format. That's what it would look like. There's a 3 foot by 6 foot by 7 feet tall power cabinet, so slim but tall. And by the way, the reason why we have such a low footprint for such a high power output is because some of the equipment is not in the cabinet. It's actually under the bus in an unutilized space. There are ground coils and the corresponding vehicle coils, which are a mirror image of the ground coils. And by the way, when I say coils, they are copper windings, not unlike a typical transformer. In fact, our equipment is literally an air gap transformer, just with a much bigger gap. Next slide. Okay, so how does it all work? Well, the power cabinet energizes the ground coils, which in turn induces a current in the vehicle coils. And they're the same geometry, by the way, different profile. The ground coils are big and heavy and they're in the ground, but the vehicle coils are very low profile, very light. The vehicle coils then convert instantaneously the AC current to DCFC and send it to the batteries. So it's important to note that the power leaving those vehicle coils is DCFC at that point. The vehicle actually does not know the difference. It doesn't know it's wireless. It thinks it's plugged in. Next slide, please. Okay, so how do you install it? The answer is very easily and very quickly. We ship the equipment to you, to site. Typically, local contractors, often having never seen this equipment before, will do the trenching and lower the ground coils and the vault into place. It's a complete assembly when it arrives. The cables are then connected, between which we ship you the cables cut to length, connected between the ground coils and the power cabinet, and then we commission the system together with the buses. So that's when we come in. And now I've actually posted, you were just mentioning how long does this take. So it takes us longer than 24 hours. That's very commendable, Electreon friends. I posted a time-lapse video on my LinkedIn page of this happening all in 1 week, start to finish. But that includes, mobilizing on site and the vehicles all being commissioned and put into service. So pretty quick either way. And the takeaway here for you is that although wireless inductive sounds high tech and complicated, it actually isn't. It's off-the-shelf components. It's basically it is an air core transformer, just configured in a different way. And all the equipment is typical stuff. So you're cutting the surface, you're backfilling, there's PVC pipe, there's conductors in the pipe, you're terminating lugs. That's it. And then the similar to, I'm sure, our friends at Electreon and WAVE, the O&M is a piece of cake. It's like visual inspections every quarter. All right, next slide. So What do you achieve if you endeavor to do this, as many have? Here's an agency in the northern US, Link Transit. This was featured in Electric Autonomy, and so this is actually their numbers. I was interviewed by Link, they interviewed Link Transit, different online numbers. So they experience very similar conditions to what we encounter here in Canada. And here's what they've been able to accomplish with our technology. So very long range in very tough conditions. And by tough conditions, I'm talking heavy snow, high elevations, highway speed. As Roman mentioned, you're stuck in stop and go traffic, no problem. You can drive around forever, almost, it seems, in a battery electric bus. As soon as you get the speed up there, the average speed, I would say over 25 kilometers an hour, definitely over 30 kilometers. So certainly any BRTs or express routes, any of that stuff, a battery electric bus, you're not going to see the performance at all like you hear about on some 40-footers that are just sort of totaled around town and, oh, we got 16 hours. The conditions change everything. So anyways, through doing that, we also avoid deep cycling. So we take very good care of the batteries, which on all of these buses have not even, let alone been replaced, they have not even compromised the state of charge warranty. Okay, all while achieving a 1-to-1 diesel to BEV replacement ratio, and that's been ongoing for 8 years. And I might add, I heard earlier talking about smaller battery size, 352 kilowatt-hour batteries on those buses. So it's amazing. And until you stand there and watch it go around, it's hard to believe. And all of that, by the way, 4 chargers at a central intermodal terminal, 1 charger at a end of the line run up in a ski mountain, literally, which is where that photo on the left is from, and then a new charger that's just been installed at another end of the line run. So a lot with a little. Important to note that they are currently at Link Transit 50% battery electric, which is commendable for any technology, you name it. They will be almost 80% by the end of this year. Those buses are on order, they're on their way. And they'll be 100% in the next 3 years. All of this is wireless. So they will be the second agency, to my knowledge, in North America that is 100% battery electric. The first of which I think was APMT, and I think that was WAVE. So also wireless. This is what you get with wireless. It's truly amazing. Next slide. OEMs. So hot topic, but this is improving. So we are a factory order option on the buses you see here, all of which are available to order as wireless right now. The EMC was just announced this week. This is game changing, especially for Canada. There's a 3rd big bus in Canada, and boy, is it a beauty. It's got all the ratings, all the things we look for in Canada, and it's got like the most of everything, the most capacity, the best stainless steel. I'm very excited about this, and I'm even more excited because, of course, it features wireless charging. And the Damera that Roman was talking about earlier, that will be revealed at OTE. Damera, Roman, I hope you don't mind. I made a little rendering there of a bus. Don't worry, it doesn't actually look like that. They'll show you what it looks like at OTE. And speaking of OTE, I will be there. Yeah, I will be there at the EMC booth because we're going to have an actual bus in real life. And you can come and meet the EMC team. You can come and meet the CityView team who represents it and services it Canada-wide. And most importantly, you can meet the bus. Okay, next slide. Okay, so I got a couple of slides here now. Where are we at? Okay, there's some time. Well, not much time left. About common questions. So this is common questions I often get asked. Then I have a slide that's questions that you sent in ahead of time, and then hopefully we'll get to some real-time questions. So questions I often get asked. So are there standards for the vehicle side equipment? So coils up on the bus? Yes, there are. So they conform to SAE-J 1939 and 1455. Which covers the communications on the CAN bus and the environmental parameters. Are we OCPP compliant? Absolutely we are, and we're validated on many popular CMSs. Any OCPP ready CMS can connect to and fully control our equipment. Is the charging interface standardized? This is what people normally mean when they say, oh, when's standardization coming? So as I think we heard, the low power has already been published, the 54-1. 54-2, which is relevant to us, is, you probably heard, it sounded like they were saying it was lagging a bit. It is, so it's expected to be late 25. I think it's going to be a little bit later in early 2026. Okay, can you automatically restart? And this is very important if you're operating these systems, and whenever there's a failure to charge, or whenever one sees, oh, something's not happening, well, with us, we automatically restart. So humans do not need to be dispatched to touch or turn anything on or off. You don't have to turn breakers off on the back of the bus, or unplug or unplug. You don't, none of that. So that's in the event of a fault. Usually, now, if a fault cannot be cleared, which would become a failure, the remaining pads keep working. So I'm not going to say we don't have faults and failures. We do, everybody does. But we have literally 4 independent parallel charging systems going into this bus at any given time. So even if and when there is a failure on one of the pads, and it's almost, I'm not going to say impossible, extremely unlikely that 2 pads on the same bus would fail at the same time. But even then, we have the automatic restart. But if there are 2 total failure or 1 total failure, the bus stays in service, or if it's in the depot charging, it stays charging. And that's not because we're smarter at building power electronics or systems. That's just the inherent nature of our equipment architecture. Is it safe for heavy vehicles? Absolutely. It's HS20 load rated. Any issues with snow clearing? No, not at all. You do need to clear the snow, though, so that different answer to a different question, because if you don't, it can raise the, if it compacts too much, it can raise the vehicle height up too much. That doesn't happen. It's surprising how much snow you can compact before that becomes an issue, but you do have to have regular snow clearing. But anyways, our equipment is in a steel reinforced concrete vault, and it's slightly below the grade, so it's tough and out of the way. Do you offer an extended warranty? Yes, 12 years, which is roughly the life of the vehicle. Is it safe? Yes. The equipment is all UL compliant, and the operation of the equipment is ICNIRP and IEEE guidance, respects the guidance for EMFs. Okay, next slide. All right, so these questions were asked by you as part of the registration for this 3rd session. I'll do my best. So is it interoperable? Yes. So all the vehicle classes as shown on the screen, plus double deckers, can be charged by the same charger. Like not the same type of charger, the actual same charger. So if you had one 4-pad or 2-pad or 1-pad charger, you could roll any of those vehicles, including a double decker, over top of it, and it would pick up as much charge as it has on the bus by intervals of 75 kilowatts. And that's because we work from the vehicle down. I think someone else said that on an earlier presentation. So there's no like heights from the roof, or, you know, there's none of that. Cable reels or pantos, you don't have to mess with any of that. It's the same thing, very consistent. We have vehicles in every class, but we might not have vehicles in every class that you have preferred vehicles for. In that case, we would need to work with any vehicles and become they would need to accommodate us. But at this point in time, we're on more vehicles than not, so it's accelerating. What is the energy transfer efficiency? 91%. That's a real world number. That's from the grid to the battery. That's out in the field with our deployments. That's an aggregate across time and across deployments. That's the number. That's not a test bench ideal conditions. Now, is it quite as high as a typical plug? No, but it's comparable and it's close. What is the vehicle alignment tolerance? It's 4 inches forward and backward, 4 inches side to side. That may sound like a small number relative to the length of a 40-foot or a 60-foot bus, but you have to believe me, it's not an issue for the operator. They hit it often. It's not a challenge. We also have training to support that. But the real reason is because we have digital guidance systems, because we can detect the magnetic field. So they're not eyeballing it. They're not looking around at cones and things. They're looking at a digital screen that shows where they are in real time. How does wireless vary from pantograph and plugs? Greatly, in many different ways. It totally depends. But if I had to give you one answer right now, I would say with wireless, we can help you achieve a 1-to-1 diesel to BEV replacement ratio for your entire fleet. Not the easy stuff at the beginning, not everything under your spares ratio, for the hard stuff all the way to the end, and give you a consistent infrastructure that everything can use. Infrastructure requirements compared to pantographs and plugs. So typically there's less required for pantos and typically more for plugs. When are Flyer, I love this question, when are Flyer and Nova going to have, okay, time's up. I'll try to be quick. When are they going to have you on their 40-foot and 60-foot buses? We have a healthy dialogue with both of them. There are no objections, but they're all hands on deck priority right now is getting buses built and delivered and getting through that backlog. However, they will likely accommodate us soon unless they want to miss out on the Canadian wireless required RFPs that are coming. And that's not my opinion, that is happening. So there's one more on cost, but I'm out of time, so we can leave it at that.
Thank you so much, Adam, and thank you for taking the time to go through those
I tried to get through all of them, and I'm never
in.
quite able to.
I know there are a lot of questions that definitely will keep engaging with our members to answer and get through all their concerns. So if there are any more, feel free to send messages to Adam directly or even to me. But for now, I'm going to proceed to our next presentation. Our next presentation, we have with us today Ben Oslander from WAVE Charging. It's our first time to invite WAVE Charging to present to the CUTRIC network. So let's all listen in and give him a warm welcome.
Thank you. Thank you to the whole network. Really happy to be here making my initial presentation. Want to just say real quickly to Amit and Adam, great job. You guys are helping push this industry forward, and we appreciate all the work you guys are doing because wireless really is the future, and we all need to keep moving in that direction. So thank you for that. Go ahead, next slide. Quickly about WAVE. WAVE stands for Wireless Advanced Vehicle Electrification. We have deployments that include 125, 250, and a 500 system. We offer our clients superior energy management software so they can see what's happening in the cloud. Again, our deployments are generally focused in transit, but we also have a commercial warehouse logistics and deployments at the port, along with an interesting deployment at an amusement park in California. Next slide. So we've gone through quite a bit of how this works. And normally when we're presenting, I would be the first to kind of walk a fleet through or a transit agency through how this actually works with the magnetic field and a receiver pad and a ground pad. And I think you guys have gotten a little bit of that already, so I won't go through it too deeply, but if you just keep clicking through, you'll see a bus drive over the pad and it pulls over a 250 kilowatt pad where the power electronics are charging it through a magnetic field. And a bus that stops for 5 or 6 minutes can pick up over 10 miles of range in a short amount of time. Please click through. Yeah, thank you. You can go keep moving through on to the next slide. So opportunity charging, and this is really the value of wireless charging, and this is what differentiates us from the plug. Realistically, it reduces downtime, so you can have fewer vehicles that are required to complete routes. There is an ROI in our system, and we do this through a charge station ratio. What I mean to that is, usually if you're just depot charging, you need one plug for every vehicle. In many of our fleets, what we're seeing is sometimes 4 to 5 vehicles per pad. So you can see that's where you could really hit the ROI. We've also seen with some of our fleet customers, our transit customers, a battery size reduction. Maintaining that constant state SOC between the 40 and 80% range, that allows you to improve your battery health. So you'll see less degradation over time. And then obviously safety. Really, it's super easy to use. The bus pulls over the pad and it works. Go ahead to the next slide. This was some footage taken from one of our clients from a drone. I think it's just to be able to visualize it in motion is pretty cool. And so I'll let the video speak for itself. But this is a client that, this is a transit agency in the US that has almost 70 buses now running. and 16 different pads. And you can see the bus pulls over, it aligns with the pad. There's an HMI in the vehicle that triggers the driver to say it's aligned, and it works, and it starts charging. Really easy. And this particular fleet is able to maintain its operations throughout the course of the day, driving hundreds of miles in some instances. Next slide. So I'm going to do it. I know that Induct and Electreon didn't, but I'm going to talk about why the depot and the overhead pantograph is not the way you should move forward. And I see some smiling there. But what we know from inductive charging is it's safer. There's maintenance benefits. It's low profile and low visual impacts. And then when you compare it to the depot, man, the cords are getting cut. There's clutter, people tripping over them. They're heavy. All that stuff that makes it really challenging for big depot, style plug-in. But then you also look at the overhead and the pantograph. There's community concerns, ADA compliance. And man, when you have to send someone up there to fix it and climb up there, it's just really dangerous and scary. So we've heard when I was recently at a transit event in North America and US, and I heard how frustrated a handful of different transit fleets were with their current overhead pantograph deployments, and we're trying to move off it. So I said that. Next slide, please. WAVE offers a platform. I think this is important because you as a fleet need to understand what power is being delivered, what's the max power available. You want to be able to pull data on the performance of the system and things of that nature. And so we offer a cloud-based platform which is operating in real time, and we're pulling information both from the vehicle and the charger. It's connected through telematics. I saw a question earlier today about how is it connected, what is the requirements. So we have a 4G chipset that is both in the vehicle and in the charger, and it's pulling data, sends it right to the cloud, and you can see it in real time. Next slide. We have quite a bit of existing IP. I don't need to go into this in too much detail. We have a handful of patents issued and more that are pending, which protect our novel approach to certain elements of the charging system. Go ahead, next slide. So I'll stop there. I really breezed through it, but I know you've gotten a couple other insights from both Electreon and Induct. At this point, we're happy to be here answering any questions you might have, and I appreciate everybody's time.
Thank you so much, Ben. That was really insightful. And, here, the reason why we're hosting sessions like this is to make sure that everyone's informed about all the solutions that are out there. So thank you for the highlights that you mentioned. Does anyone have a question for Ben?
I went quick so that you could ask questions.
Anybody? They're speechless as well, then.
Happens.
It happens. Okay. Are there questions?
I would just a confirmation, Ben. It is you at AVTA, correct?
I'm sorry?
It is WAVE at
Yes.
Antelope Valley, and that was the first 100% fully electrified fleet, was it not?
It was.
Right. Yeah. Great stuff.
There's a question in the chat addressed to everyone. To all, are the products CSA or equal? Hi, Robert. Do you want to go on camera, turn on your camera and ask the question and elaborate?
I can ask the question. Just looking to see if there's CSA equivalent or CUL or those sort of questions.
Is that like a certification?
Yes.
Oh, so we field certify with UL on all of our units.
Yeah, Rob, I just put it in the chat. So we're UL as well and CUL in Canada.
Thank you. Amit, did you want to answer that question as well before I read the next question?
Sure. Yeah. I mean, we comply with all the European standards, field certification on the UL side as well.
Okay, thank you. And the next question is, what are the current challenges in wireless charging? I know that it was mentioned by Katrina earlier, some of them, but maybe unique to you, like if you can mention like what's the biggest challenge so far that you've encountered?
I can go. That's not a hard question for me unless anyone else would like to start.
Go ahead, Adam.
So really the challenge is where a transit agency is at in their planning and deployment from my perspective. So if they have already planned, sunk all kinds of money into planning and approvals, chair board approvals, and then even further gone on to start procuring tens, hundreds of millions of dollars of what was recommended in those studies. Even when they realize what has happened and how different this technology is and what it means in terms of a different level of operations, and when they're happy with that, it is very, very difficult for them to unwind and change course. And so I actually spend a lot of my time managing that. It's often a no-brainer connecting to the agencies quickly. But so the sort of institutional thinking and process is my number one challenge.
Yeah, Adam, I think a lot of that makes sense what you just said. I would just throw on to the hop of that. Again, it's still early days for the wireless charging industry, and it's that mental mindset that change. First of all, getting transit agencies to even buy electric buses, getting fleets in transit to buy electric is the first challenge, and then understanding that wireless is a better mousetrap and getting that mental makeup around the benefits and how it can improve a lot of different items is, that to me is probably the other big challenge.
Thank you for your responses there. I see another question in the chat. We have 3 minutes left. There's a question on safety requirements while the buses are charging. For this technology, is it safe for the passengers and drivers to remain on the bus? And can pedestrians walk past the charging buses?
Yeah, so thanks for that, Steve. So there are safety measures that are taken into place in terms of the safe distance that pads have to be located underneath the vehicle, how close they are. But that's already been taken into account with the engineering and integration. And so the answer is yes. Pedestrians, operators, they can walk around the bus, they can walk inside the bus. You just would not want them to get underneath and slide under the bus during a charging event. Now, it would be shut down, but it would be disruptive. So there's no issue. And our customers, so the bus operators, they do their own testing. It's cheap equipment. You can check for the EMF field level, and they've found like the heating coils in the seats, heated seats, give off more EMF where the seats are than our equipment does. So it's perfectly safe because it's integrated, designed and integrated, as Roman was saying, correctly.
We have tens of thousands of charging events, never had one problem. And interestingly, my wife asked if we ever fried a cat or a squirrel, and we haven't done that yet either. Like I said, it's perfectly safe. There is no risk. People with a heart condition, not a problem. We had extensive testing by NBC when we did an implementation at Universal Studios, because that was one of their concerns, right? And the liabilities around it. And so we passed all those tests with flying colors.
And I'll just add to that's exactly the subject of testing that we are supporting with SAE, and that's what's being done and evaluated to guarantee and to standardize that across all platforms and all wireless technologies.
Thank you, everyone. Very interesting discussion and questions. I know there might be more questions moving forward. Please feel free to send them to me. For everyone on the line today, I'll also be sending you the email addresses of the presenters in case you want to deal with them directly. So I'll do that. And as you exit, you'll see a post-session survey asking about the level of interest. This will just help me know what kind of outreach to do with you. I don't want to bug you guys too much, but let me know what your interest level is so we know how to move forward. And I'll be announcing soon a regular deep dive so that we can, as a consortium, decide how to move forward and put this additional solution in our toolkit. And I'll definitely reach out for one-on-ones. Thank you again, everyone. And this was very helpful and insightful. Have a great day.
Thank you. Thanks, Jenny.
Bye,
Thanks to
guys.
the team. Thanks for putting it together.
Thank
Thank
you,
you.
everyone. Bye-bye.
Bye.
Great job, everyone.
Take care.
Thanks, guys.